हाय फ्रेंड्स। हेलो। सो कैसे हैं आप लोग? सो उम्मीद करता हूँ यू ऑल आर गुड एंड फाइन। तो आई एम बैक अगेन with a new video, with a new session on Kubernetes, horizontal pod autoscaler topic. So before starting this session, I would like to request you all, please subscribe to my channel Nirmal Technical to get a new video and like this video. Thank you all. Thank you so much, friends. So today our live agenda is about horizontal pod autoscale. So firstly, let me tell you what is the autoscale in Kubernetes. So autoscale in Kubernetes, it's basically about talking about pod. So increase the number of pod and decrease the number of pod. This is somehow autoscaling in Kubernetes. So horizontal pod autoscale works on uh, load of CPU inside a pod. So it's horizontal pod autoscaler basically works on load of CPU, that CPU utilization, you can say basically. So what is the actually main use of this horizontal autoscaling in Kubernetes? So HPA, horizontal pod autoscaler, is an object, such kind of object, which is capable to autoscale in Kubernetes. So what is the use of this object actually? Why it is used in Kubernetes horizontal potato scale? So the concept is behind that. Let's say one service is running in pod inside a container. If I'm talking about pod, so of course I'm talking about a container in that way, and the user will increase. Okay. So if user will increase to get a service, of course the load will be increased in that pod. If the load will be increased, so need a more pod in that case. So auto scale, horizontal pod auto scaler is a such kind of object which is applied in Kubernetes to get auto scale in Kubernetes. That means it will be increase the number of pods based on the CPU load. The CPU utilization will be decrease the number of pods based on the CPU utilization. So one more thing, actually horizontal pod auto scale, it does not works only. Actually, there is one more API. There is one API with that help of that API, horizontal pod auto scale is capable to do auto scale in Kubernetes, and that is called matrix server. So, what is the role of matrix server in Kubernetes? Actually, matrix server take the matrix for a pod. So metric, what is the mean of metric here in this Kubernetes? So metric what means that what CPU utilization is used, what CPU utilization is used in pod, inside a pod, how much memory is used in pod. So such kind of information, metric server to get from the pod, then this information will be provided to HPA, that means horizontal pod autoscaler, and based on the CPU utilization, let's say the CPU utilization increasing, so such kind of information horizontal pod autoscaler get from which API, that is called matrix server. Matrix server provides that kind of information to horizontal pod autoscaler. Then horizontal pod autoscaler calculate the number of replicas. See, if the, let's say if we have set a CPU utilization 20% inside a pod, and later then CPU utilization is going to increase or increasing 30%, 40%. Then based on that, horizontal pod autoscale will calculate the replica. The replica, that means number of pods, and then it will ask to deployment object. Deployment object, yeah, replica set object to increase the number of replicas. So this is how the process, the how HPA work, what is the actually main use of HPA in Kubernetes. And one more thing, right? I am just shared with you overview about that HPA and matrix server for detail view and detail way and depth and knowledge. You can go you can access that Kubernetes official website. Official, there is more documents, more details, everything is there about Kubernetes in that official website. So you can, in point of study, you can read and everything is there. Okay. So this is somehow that HPA, horizontal pod autoscaler. So basically what I told you earlier, that horizontal pod autoscale do autoscale in Kubernetes, then autoscale, that means increase the number of pods, decrease the number of pods based on the CPU utilization. And CPU utilization, who will provide this information to horizontal pod autoscaler? So this kind of information will be provided by what? That API that is called metric server. So let me, I have just prepared one Word file. So let me share with you all. So what is a horizontal pod autoscaler? So horizontal scaling means that response to increased load is to deploy more pods. So if load is increased, then more pod will be deployed. That is called horizontal pod autoscaler. Also, it does not work only for that increasing number of pods. In reverse direction, if the load will be decreased, that means load will be decreased inside a pod. So here I'm talking about load. Load is CPU utilization. Don't get it confused. Yeah, here load, that means I'm talking about a CPU utilization inside a pod. So if load will be decreased, so of course the number of pod will be decreased. And this is the diagram of how does HPA works, horizontal pod autoscaler. So here you can see the metric server, which is applied above a deployment object, pod 1, pod 2, and pod n. There might be so many pods in the real environment. So every 15 seconds, horizontal pod autoscaler get the information from metric server. Query for matrix. So matrix, what is the matrix? I am again telling you matrix, that is how much CPU utilization is going on that pod, inside a pod, how much memory. So these kind of information are called matrix. Later then horizontal pod autoscaler calculate the replicas. If horizontal pod autoscaler see the load is increasing, then it will calculate the number of replicas. Replica, that means called pods. Then horizontal pod autoscaler will communicate to deployment object to increase the decrease the number of pods. So this is how the process, how does HPA works. What I am sharing with you here in this picture, via picture, and what is the process to get implemented how to horizontal pod autoscaler in Kubernetes cluster. So this is the process. What is the process? The first step is to download matrix server. I will download the matrix server on master node. Then I will see the matrix server.ml file is there or not. After that, I will edit this file. Later, then I will add this content under deployment object. Then I will apply changes. Then I will create a deployment object, and finally I will implement auto scaling on object. So what is the command of that? To implement this is to get it implemented in this Kubernetes cluster. So kubectl auto scale, then deployment and the object name. So I have set I have created deployment. So and deployment name is Nirmal. Let me share with you. This is the test file. You can see the current deployment API version apps oblique v1 metadata. So name is deployment. Okay, let me to change it name here. Nirmal, and then replica is equal to 1, selector match libby deployment, template, metadata, test port. So one more thing, always remember, while you are going to apply object deployment or application controller or replica set, so these match labels and labels, these both information should be similar, should be same, not a different. I'm going to create a container, one container which name is C00 and Apache server, and then finally I have set the request resources. So in previous session, I have already shared with you what is the resource quota, what is the actually resource quota in Kubernetes. So there is a CPU and memory and container, what you can define in a resource quota. That is a limit and request. Oh, all the details about the resource quota in I have said in previous session. So I will not explain here because this will be more lengthy. So this is the one manifest file for the deployment object. So first, now I'm going to share with you how to do implement horizontal pod autoscaler. Now how does it work? So I will share with you practical. So I have already done cluster setup of Kubernetes. So you can see kubectl get node. So it's fine and working. So M that means master node and W part is worker node. So first command, let me do fire on this. So starting from here to download metric server. Now I'm going to implement horizontal pod autoscale on Kubernetes. So this command I will fire here. Okay. Now what is the second step is that to see file in master node. So ls. Okay. Then what is the third step? To edit metric server file. So vi. Okay. Press I on your system. Later then I will add this content under deployment in this file. So here I will add this content. Okay. Again, I'm sharing with you. I have to add this content under deployment object. So I have added this content here. Kubelet insecure.tls. Then press escape on system. WQ. And let me do apply changes for this file. So remember kubectl apply -f. So kubectl apply -f metric server then ynl. What happened? Oh, my mistake. Yes, you can see Matrix server created. So now Matrix server has been successfully created on Kubernetes cluster master node. So next step, what is the next step? So object deployment creation. So before going object deployment creation, let me show you some another things. So press Ctrl L, cube, CTL get. Remember, you guys do not remember how to see the namespace in Kubernetes cluster. So there's your command cube CTL get namespace. Yes. I want to show you one thing. Let me show you. So cube CTL get pods and then hyphen name and specific namespace. You can see I have downloaded, actually I have that implemented Matrix server on this Kubernetes cluster. So actually this uh, Matrix server will be implemented under this kube system namespace, not in default. So you can see kubectl get ports hyphen namespace, then that particular namespace name. You can see the Matrix server has been implemented successfully. Okay. Now what is the next step? Now I will do implement this deployment. Okay, let me to close this. Already I had been open my YB. So okay, I will do I will do create deployment object. So let me tell you this client is deployment API version apps v1 metadata So my deployment object, I have set the name Nirmal. My name is Nirmal. Okay. In specifications for replicas, I am going to create a replica is equal to one. That means one pod will be created. That means one container inside that pod will be created. So I am talking about pod. That means I am talking about container. Okay. So selector match labels, then name nil deployment, and that pod will be named. Pod name will be test pod. Labels deployment. Container C0 Apache server, and that container I'm going to expose the port of container, that is 80. So control L. So vi dp.ym. dp, that means deployment. Okay. Press I. Oh, press. You can see that deployment object. The name is Nirmal. Then I'm going to create a one pod inside the deployment object test pod, and the container name is C0 inside this test pod. Okay. And the deployment name object, this is the deployment. Actually, this is the object deployment. I tell you actually one thing. I'm telling you one more thing, that auto scaling can be applied on the some specific object, not for the all things. So auto scaling, horizontal port auto scaling can be applied or can be implemented on the objects, such kind of object like deployment, replication controller, replica set. In such kind of object, we can do implement auto scaling, but it is for the some specific object. What I'm telling you, that it is not for all the object. You can say it is for the deployment object, replica set. So, and later then you can see that Apache server where container port is at 0, and resources, what I have shared you in previous session. So it is limits. So CPU limit is 500 milli CPU, and request is CPU is 200 milli CPU. So one more thing, guys, what is the limit and request? So request is a minimum requirement. That means for a pod, it cannot be less than the request, and for limit, that is for up to maximum configuration. So CPU cannot be more than 500 milli CPU for a pod. But one more thing, actually, this is the definition what I, this is the X criteria what I set. You can set another, that is not exactly default. That means you don't need to get it. You don't need to like take it as a default setting. I have just set the limit CPU 500 milli CPU and request 200 milli CPU. You can change as well this, but there is one also a criteria for a at least default setting for a pod. Okay. Then press escape on your system and WQ. Now let me do create a deployment object. Let me do apply the changes on this file. So cube ctl apply -f dep.yml. You can see the deployment object which name is Nirmal. It successfully has been created. So cube ctl get deployment Nirmal. You can see the ready 0 by 1. So it will take some time. Yes, it will take some time. It will take some time. There should be 1 by 1, not 0 by 1. Yes. Now you can see 1 by 1, that is one deployment object, and it is successfully running up to that one. You can see also the pod cube ctl get pod. So you can see that one pod is successfully running 1 by 1. That means you have created one pod. Inside this pod container is successfully running 1 by 1. That is inside that pod, one pod is container is successfully running. So our lab agenda is auto scaling. Till now, I have just followed this process up to get it successfully implemented. So final step is I have to share with you. So till now, what I have installed metric server. Then I have created a deployment object. Finally, let me do fire the command for auto scaling. So kubectl auto scale deployment and a deployment object name is Nirmal. Then this is a very important thing. CPU percent I have mentioned 30. It means if CPU percent, that means if CPU utilization will increase more than 30, then pod will be start to increasing. Then pod will be start to increasing the count. Yeah, you can say the pod will be in start to create. Okay, by autoscaler HPA horizontal pod autoscale. So let me fire this command. kubectl autoscale deployment. That deployment name is Nirmal. CPU percent 30, minimum and maximum 10. You can see horizontal. You can see horizontal pod autoscaler dot autoscaling Nirmal autoscale. Now it is successfully autoscale. Now let me share with you very interesting. So let me do fire one command. Watch kubectl get all. So you can see there is one pod which name is Nirmal. Uh, no. There's a one pod which name is Nirmal dash 865.8 which is successfully running. Inside this pod, one container is running. The service Kubernetes cluster IP. This is the deployment object. You can see that this is the deployment object which name is Nirmal and one by one ready and up to date one and available one. Friends, now let me show you how does automatically pod will be created. I will show you. No worry. It will be more interesting. It will be more good. It will be more interesting to see this. How pod will be automatically created, but based on the CPU utilization. Now you can see. Now you can think how I can do like how CPU utilization will be increased. So for this, I can do one thing. I will access this container. I will access this pod. You can say I will access this container, and I will do some fire the command. So when command I will do fire, so CPU utilization will be increased. Then you can see here is the one pod only. So number of pod will be increased. Okay. So let me do take a duplicate session for this master node so that I can share with you properly how auto scaling is working. Wait. See, you can see every 2 seconds kubectl watch kubectl get every 2 seconds it will refresh. Okay, so I will access this pod first. What is the command? You don't get it confused. This is the both are the same server, but I have opened the duplicate to share with you how does auto scaling is working. How does pod will be increase? How does pod will be create automatically? I will not do anything. I will just increase the load. I will just increase the load for CPU. I will just increase the load for the CPU in particular pod. Then pod will be automatically increase. It will be very interesting. See it. Okay, so cube ctl execute in track mode. Then pod name. The pod name is this and hyphen hyphen slash win slash bash. So I have accessed the Apache server. So what I will do again, I am telling you, don't get it confused. Again, I am telling you. I have accessed this pod as per definition what I have shared with you. If inside a pod CPU utilization will be increased, then pods will be automatically increased. Increased means the pod count will be increased. You can see currently one pod is, yeah, you can say one container is only running. One pod is running. But here I will do changes. You can say I will do fire the command to increase the number of, increase the CPU utilization. Then you can see here the pod will be automatically increased. Okay. So let me to fire and how based on that CPU utilization. You can see, I will tell you, don't worry. So apt update -y. You can see here load will be increased. You can see the load increasing now. It went 31%. Again, I will fire this command. Yes, you can see 235% load went. Then you can see the pod automatically created. I am not doing anything. I am just doing increase the load of CPU. You can see the pod is automatically creating here, and the load is increased 140%. If I will again fire this command, then again load will be increased. You can see, yes, 191% load. So also I will tell you 191%, that 30% maximum. So 191 by 30. So it should be the port count 6 or 7. So you can see here 1, 2, 3, 4, 5, 6, 7, 8. And honestly, you can see I am not creating anything. Pod are creating automatically. You can see here based on the CPU utilization. CPU utilization you can see here. Now you can see the CPU utilization is again now decreasing. So automatically pod will be also deleted or a pod will be terminated automatically. But there is a cool down time. So you can see also see here. I will not do anything here. Pods will be automatically deleted. But for deletion, I just forgot to tell you one thing. There is a cooling down period. It's not, I don't exactly remember what, but I think that is 5 or 10 minutes. So after 5 10 minutes, all ports will be deleted, but there should be at least one port because I have set a minimum port, minimum count is equal to one. So there, all these ports will be deleted automatically. You see, I did not create any port. Firstly, I created a deployment object. There is a one pod only, but later then these pods are creating automatically. I'm not doing anything. This is called horizontal pod auto scaling. You can see the CPU utilization went to 0%. CPU utilization went to 0%. So all these ports will be deleted automatically. It will take some time. That is a called cooling down period. So friend, this is called horizontal potato scaling. I believe you guys uh, have understand what is horizontal potato scale, how does it work uh, based on the CPU utilization. It will calculate the number of ports, number of replicas, and this is very interesting topic. You can see the pod will be deleted one by one because the load it is targets to 30%. Okay, and also minimum pod is 1 and maximum pod is 10. So maximum pod can be created up to 10. If load will be increased more, then maximum pod can be created 10, and there should be at least one minimum pod in this deployment object. So you can see, and replica is equal to currently 8. So 8, that means there should be 8 pods. You can increase the count 1, 2, 3, 4, 5, 6, 7, and 8. But of course, the load has been decreased, load went down to 0%. So these pods will be deleted automatically as per process, as per the horizontal pod auto skill. You can see replicas will be deleted automatically. But there is a one cooling down period that is called something 5 or 10 minutes. I don't exactly remember. So during that period, after this particular time period, 5 or 10 minutes something, then pod will be start to deleted automatically. So you can see 0 by 30 minute because I have said that CPU utilization up 30%. If you want to see, you can see here. CPU percent 30 means. So that what does it mean? CPU 30 here. Targets. Target 30%. If CPU per load will be 30, so there should be only one pod. If the load will be increased more than 30, 40, 50, 60, then based on that, replicas will be increased. So dears, it's taking some time to delete the pods because I told you that there is a cooling down period. Then later then pod will be deleted because the load already decreased. Friends, now hopefully you enjoyed this session, how to do implement horizontal pod auto scaling, and hopefully you will be take you will get a understand you will understand. Of course, you will do implement. Thank you so much. Thank you all. Thank you so much. Now you can see the pod are automatically are deleted. Some pods are remaining, but it's automatically are deleting. Now replica is equal to 4. Finally, there should be only one pod, as I told you. Yes, you can see only one pod is remaining. All the remaining, only one pod is remaining, but less other pods has been deleted. Minimum pod is 1, maximum 10 pod, and replica is equal to 1. So guys, I believe you all enjoyed this session, and it is very important topic in this Kubernetes. Thank you so much. Thank you all. Good night.